here is the starting of circular motion. Okay. Now for circular motion, let's see the explanation over there. Okay, so an object at steady speed in circular orbit is always accelerating as its direction is changing, but it gets no closer to the center. Okay, so what are they talking about? I give you some example. Object in circular orbit. So let's say the sun and the earth. So the earth is moving in circular motion around the sun. So this one you should know already. You should heard before. Okay, so the red one is the earth. The white one is the sun. And we also know that the earth moves at the same speed, where it takes 365 days to move one round. So you should expect the next year also take 365 days to move one round. So you should expect it to move in the same speed, steady speed. Okay, an object at steady speed move at the same speed in circular orbit. So this is the circular orbit. Is always accelerating. So why the earth, which is moving at steady speed, is accelerating? Okay, let's see. Acceleration is v minus u over t. Okay, v minus u over t. V and u are final velocity and initial velocity. Both of these are vector quantity. So vector quantities, they have magnitude and direction. Magnitude means the value, the speed, and the direction. Okay, now let's say the earth again. The earth moves at the steady speed. So let's say the speed is x meter per second. So at one point the earth will come here, it moves at x meter per second. Okay, so let's say this is the u, initial speed. This is the v, final speed, final velocity. Okay, so you can see the u is acting to the right, the v is acting down. Okay, so although they have the same speed, the same magnitude, but they have different directions. Okay, because of that, the v and the u, which are vector quantities, right? They have the same magnitude, but they have different directions. Okay, different direction. So end up with, when this minus with this, you won't get 0 one. You won't get 0. Okay, you won't get 0 because direction is affecting that. So of course, how it affect, that is the problem of vector. So where we are not going to care about vector now. Okay, so the thing is, you just need to know, because of the difference of directions, it makes them different, and you minus, you won't get 0. We don't take the speed x minus x, we take the vector to minus something minus something, which end up with non-zero. So non-zero. So because of that, we say that the earth is accelerating. is accelerating, because you can't get 0. You can't get 0, that means A has values accelerating. But the accelerating here doesn't mean they are getting faster and faster, you know. It's not getting faster and faster. It is accelerating that causes it to move in circular. So that's why we had to learn something like this. Acceleration that we learned beforehand is making the object faster and faster. But here, the accelerating in circular motion is making the object remain in circular orbit. Okay, so I write down first. This acceleration keeps the object remain in circular motion. Okay. So a little bit more details. You know, F equal to ma, right? This is what we learned just now, where that time I said Newton's second law. Okay, but over here they don't mention Newton's second law at all yet. So, but we still need to take it. If this is not 0, where I already explained, it's not 0, then the force is not 0 also. So they're supposed to have a force. Because acceleration is not 0, then force is not 0 as well. So what kind of force is acting on the earth? So that the force is known as centripetal force. Centripetal force is what force? It's the force acting towards the center of a circle. Okay, so which means there is a force acting in this way. When the earth is on top, when the earth is here, then the force is acting here. Centripetal force. When the earth is here, the force is acting to the center of circle. Centripetal force. Okay, so to make it more accurate, let me adjust a bit. Adjust the sun a bit. Okay, let me adjust the sun. Okay, so the sun should be adjusted until it's here. The sun. Okay, my centripetal force is acting towards the sun. Something like this. Okay, so that is centripetal force. Centripetal force is perpendicular to the motion. Perpendicular, and is acting towards the center of circle. Okay, so let's see more. It is a force that is needed, not caused by circular motion. That means centripetal force is a force that is needed to keep the object in circular motion. Okay, so for example, when you swing a ball on a string round in a circle, so something like this. Okay, so that gives us a scenario. So let's say you have your hand and your ball. Okay, this is your hand. Your hand, and you make the ball move in circular motion. Okay, because you are swinging it. Okay, so what happened is the tension of the string is the centripetal force. So this is the string. The tension of the string, which act this way, is the centripetal force. Okay, so it acts towards the center of the circle. If the string is cut, so you want to know why centripetal force is very important to keep the object in circular motion, right? So the easier way to take it is you cut the string. If you cut the string, then the ball will not remain in circular motion anymore. You travel in a straight line at a tangent to the circle at the point where the string was cut. That means when the ball is here, you cut the string. Okay, so you cut the string. Okay, then the ball will not remain in circular motion. They will move in a direction which is tangent to the, as you can see here, tangent to the circle. So that is what they are saying there. Okay. Now, next point. Centrifugal force. Centrifugal force is the force acting away from the center of a circle. This is what makes a slingshot go outward as you spin it. Okay, so have you heard before a slingshot?
Yeah.
Okay.
Something like you used to elastic thing, right?
Okay. Yes.
It's like a catapult.
Okay. So you know that, huh?
Yeah.
The centrifugal force is the reactions to the centripetal force. It has the same magnitude but opposite direction to centripetal force. So they are trying to say that they are opposite direction. Centripetal force is acting inside. Centrifugal force is acting away. Okay, away from the circle, the center of circle. Okay, so I let you see a diagram here to understand a little bit more on centrifugal force. Okay, so I put a diagram here. Slingshot and centrifugal force. Okay, let's look at the image only. Okay, let's see. Okay, so none of the pictures are suitable. Let me see this. Centrifugal. Okay, maybe this one. Okay, this one you can see centripetal force, but they never mention much about centrifugal force. Huh? Okay, so never mind. We just leave it like that, as not much information can be found from the internet. Okay, so we just leave it like this. Just remember, centrifugal force is acting in opposite direction of centripetal force. Okay, so it is used to make the object go outward as you spin it. Okay, so settle already for circular motion. Okay, we have a formula. F equal to mv square over r. Mv square over r. So m is the mass, v is the velocity. What kind of velocity? Velocity in this direction. Okay, let's say if you have an object move in circular motion. Okay. The V is the V. Let's say the object is moving this way. Okay. So the V will be this one. The V. Okay. At the tangent of the circle. That's the V. The mass, nothing lah, the mass of the object. And the R is the radius. The R. Let's say this is the center of the circle. So then you can see the R. Okay, and then the mass is just the mass of the object. Then you can find the centripetal force. Okay, so let's say one example. Okay, let's
So
see.
V is
Yes.
like the V is the velocity. V is the centripetal force.
V is the velocity.
Okay.
Velocity, which act in this direction. Okay, so F is the centripetal force. Yeah, F is centripetal. Okay, centripetal force. Now let's say one example. Let's say our object is the Earth. So our object is the Earth. Okay, let's the one the Earth lah, because I don't know the mass of the Earth. I need to search from Google. Okay, now let's say I just put a general object of mass 2 kg, and then this object move at a velocity of 3 meter per second. The radius is, let's say, 30 cm. Okay, now I want to find the centripetal force. F equal to m v square over r. So the r you have to change to meter, 0.3 meter. 0.3. Okay, then after that we go and count 3 times 2 times 3 square, divide by 0.3, and then we get centripetal force 60 Newton. 60 Newton. So that is the centripetal force. Okay. Now let's see more question on centripetal force. Okay, so we look at this question now. This is a question related to circular motion. Okay, so first of all, let's go through the question. Figure 4.1 illustrates an object on a string being whirled anti-clockwise in a vertical circle. Okay, so like this. The lowest point of the circle is a small distance above the ground. So which is this part, lowest point. The diagram shows the object at the top A of the circle, so which is here, and at B when it is at the same height as the center of the circle. On figure 4.1, mark clearly the force of the string on the object. Okay, so we need to know the force that they mentioned about here is the centripetal force. Okay, so we have to mark the force. Okay, so of course you should expect to mark in this particular way. So at A, right? So force acting towards the center of the circle. At B, so just mark like this, acting towards the center of the circle. So we have done part 1. Yeah.
So sir,
Yeah.
the one that you mark, that is the centripetal force.
Yes, correct. Which is also the force of the string. If you still remember the theory, they said the tension of the string is the centripetal force. So that's why I mark in that particular way. Okay. Now, part 2, the path the object would take until it hits the ground if the string broke at A. Okay, so if it breaks at A, first of all, you need to know one thing. Based on the information that we know, the question said this is anti-clockwise. It is whirl anti-clockwise. So anti-clockwise means this particular direction, the velocity is this way. Okay, so the velocity is acting that way. So if you cut the string at point A, so what happen is it will just follow it is initially move in, okay, I use the green color, move in horizontal, but after that, because of gravity, it will move in this particular direction. So like that. Okay, anti-clockwise. Okay, so after that for B, right? For B, of course, we have to know the idea. The idea is you have to first recognize the tangent at that point. The tangent at point A is this horizontal line. Okay, if the tangent is in that way, then you cut, it will follow the direction of the tangent. After that, it will move because of gravity and turn in this particular way. Okay, so now let's look at part 2 at B. So if you cut the string at B, first the tangent is this way. The tangent is down. Okay, anti-clockwise, so down, and it will remain down. Gravity will make it down, so it is just going down. So that is part 2. So it's related to centripetal force. Okay, now we look at part B then. The mass of the object is 0.05 kg. At A, the tension in the string is 3.6 Newton. Calculate the weight of the object. Okay, so we have to calculate the weight of the object. Okay, so let's see how we count the weight of the object. Okay, so you have to use the formula weight equal to mg. The m is 0.05, the g is 10, so you get 0.5 Newton. So that's the weight, 0.5 Newton. Okay, so then we look at part 2. Calculate the total force on the object at A. Total force. Okay, now how to count the total force? Let's see the picture first. Okay, so at point A, what we know is, let's say I draw it again. What we know is at point A, right, the weight is 0.5 Newton, which acts downward. The tension in the string is another force, tension. Okay, the red one is W. The blue one is the tension, 3.6 Newton. So since the two forces are acting downward, so what we need to do is to find the total force, we just add them up. If they are in opposite direction, we minus, if they are in the same direction, we just plus. So for this case, we plus to get the total force. Okay, so 0.5. Okay, you look at the pictures to understand it. Plus 3.6 equal to 4.1 Newton. So that is how we understand the question related to centripetal force. Okay,
So can you please repeat E number 2?
B number 2, okay, I repeat it again. B number 2, remember one thing. First, from B number 1, we already count the weight. By using mass equal to mg, we get 0.5 Newton. So you know the weight is acting downward. Okay. Now the second thing is they also give you the tension in the string, which is 3.6 Newton. 3.6 Newton is also downward. So you want to get the total force, you just add them up because they are in the same direction. So you want to get the total force. Total force is basically the resultant force. So we just add them up. Of course, if they are in opposite direction, you have to minus them. Yeah.
Okay, so I understand.
Yeah. Okay. So this question settled. Okay. So let's see the question. Figure 1.1 shows a model car moving clockwise around a horizontal circular track. A force acts on the car to keep it moving in a circle. So when you hear these words, keep it moving in a circle, you should think of centripetal force. Draw an arrow on figure 1.1 to show the direction of this force. Okay, so when you want to draw this, you have to draw towards the center of the circle. Okay, so let's say for our case here, we just draw an arrow. Let's say the center of circle is here. Just draw in this particular direction. Centripetal force. FC let's say, I label. Okay, so that is part 1. Part 2, the speed of the car increases. State what happens to the magnitude of this force. Okay, so imagine F equal to mv square over r. So if you increase the v, of course you should expect this to increase also. So the answer is force increases in magnitude. Okay, now let's continue. B, part 1. The car travels too quickly and leaves the track at P. On figure 1.1, draw an arrow to show the direction of travel after it has left the track. Okay, so you have to draw an arrow to show this. So you have to draw tangent basically. Tangent. Okay, so you have to draw this way. Tangent. So the idea is tangent. So when they can't move in the circular motion anymore, so they will move in tangent. Okay, now part 2. In terms of the forces acting on the car, suggest why it left the track at P. Okay, so 2 marks for this question. in terms of forces. So we have to keep focus on the forces. And okay, what can we say? So first we need to know what force is acting over here. It's basically the friction. The car move in the circular track. The car and the track has friction. The friction is the force. So this force contribute to the centripetal force.
Can
Okay.
it also be weight?
Weight cannot, because weight is acting downwards, acting downwards. Huh? So imagine if this is the car, that move in circle. Okay, so the center of circle is here. Okay, so what happened is weight is acting. Okay, I follow their diagram lah, because my diagram may make you misunderstand. I follow their diagram. The weight will make the force acting into the screen. Acting into the screen. When it's acting into the screen, it doesn't contribute to the centripetal force. Okay, so it must be the force that act towards the center of the circle. So that is the friction actually. The friction act in this way.
I don't really understand. Can you please repeat?
Okay, so then I have to draw a 3D diagram. So this 2D diagram is not helpful, will make you more confusing. Okay, so a 3D pictures, let's see. Okay, so imagine a circular track in 3D. So the car is here. The weight is, okay, let's say I make the car at the side, easier. Okay, the car is at the side here. The weight is acting this way. The weight is acting down. Okay, it's acting down. So centripetal force must act in this way. Centripetal force is acting in that particular way, which is acting towards the center of the circle. And because of that, you can see the weight is not contributing any force to the centripetal force, because it's acting in perpendicular to the centripetal force. So that's why there is no contribution to the centripetal force. Okay, so it can't be the weight because of perpendicular. Okay, so but the friction contribute to the centripetal force. Now what can we write is, we just write the frictions between tires and track provides centripetal force. So this one mark on it. The second mark, right? You explain why they will run out of track, because the friction is too small to provide the required force. You know, when the car is moving faster and faster, right? F equal to mv square over r, right? When the car is moving faster and faster, the centripetal force is higher, but the friction is not enough to provide this centripetal force, and then it will run out of track already and run out of circular track.